Thanks for watching my video. Today I'm going to discuss about area of segment. Okay. Now let's draw a circle. This is, let's say, center. Okay, center or segment mean this one. If the code is like this, then this is what we call a segment. Okay. And again, in area of segment we have two segment again because two segment meaning this is what we call minor because it is the small one and this is the big one. Big one is what we call major segment, and this is minor segment. So first of all we are going to find for minor segment area, this area. So through this, okay, join this two, and after that join this one. Okay, now through this, let's draw one perpendicular line. You can use scale, but let's say this is 90 degree. Okay, because it is perpendicular. When you draw it, draw it with perpendicular with this or this. Let's say A, B. This one, let's say when you draw such that BL is perpendicular to OA. Okay, just draw it like that. And this is the sector, and this angle is what? Let's say theta. Go in is angle of sector angle. Okay, this is our figure. So from this we are going to find this one. Okay, let me rough all this. Okay, we are consider only this one, this part. We are going to find the area of this part. Okay, after that the white one. So let's find. Now let AB be a chord. Okay, it is just a chord because it passed from one circumference, one end to other end of circle. So this we call chord. Okay, chord of a circle. It is a chord of a circle with center O. This is the center O. Okay, we name it O. Then this AB chord of the circle divides. Okay, it divides and the circle into, or circle or circular something, into two segments, which it divide into two segments. Okay, it divide into two segments. Let's name it here. Let me say it is X. Let me say it here is Y, so that we can name the segment. Okay, two segment then is AXB and AYB. Okay, AXB this area and AYB the major one. So first of all we are going to find for AXB, which is minor segment. Okay, now this is a construction. Before doing this you should do join OA, OB, and draw BL. This one BL perpendicular to OA. Okay, it should be perpendicular. And let AOB, angle AOB is equal to theta, which is sector angle. Now if you see here, okay, this area, now this triangle, since this is BL is perpendicular to OA, that means OLB or BOL is a right angle triangle, isn't it? So right angle triangle, and this is the sector angle. So from that I want to find out BL. Okay, BL. From that, so BL is equal to, since this is right angle triangle and this is theta, so what we can do is that use the sine, okay, sine definition. One is sine theta is what? Perpendicular by hypotenuse. This is 90, so opposite OB will be hypotenuse, okay. Perpendicular will be BL. So from this, since we want to find for BL is the perpendicular distance, so P will be sine theta into H, okay. Now just substitute the value here. BL is equal to sine theta into OB, which is the hypotenuse. Let's name this as equation 1. Okay, now we can find for area of minor segment. How can we find out this minor segment? We know that, okay, we know that this AOBX, this whole term is what? Area of sector, isn't it? So if you tell this is again this is a triangle again, so that means area of minor sector, this is the area of minor sector minus this area of triangle. If I take out, you will left minor segment, okay. Now doing so, which is area of sector, which means minor, okay, minus area of triangle. What is that? What triangle? AOB, okay. Area of sector, minor sector, we know it is pi r square theta over 360 minus area of triangle is half into, one is base here, base is OA, I think, base is OA, and perpendicular is BL, okay, BL. Why we find here BL? Because we will be needed in area of triangle, so that's why I find out this first. So which is pi r square theta over 360 minus half. OA is what? One is OA here. OA is the radius, and BL is this one. Sine theta into, one is OB. OB is radius again. So which means, and if you simplify here, let's take r square over 2 common, because here r and r square over 2 common, okay. So that here I will be left with what? Theta pi r square coming out. If I take out of 362, that means 180 minus what will be here? Sine theta. So this is our required area of minor segment. This is the area of minor segment. Now let's try to find for area of major segment, okay. Now area of major segment. Area of major segment is so easy, since we know the area of minor, so we can find easily. Area of major will be area of circle minus this area of minor, okay, that's it. So area of major segment is equal to what? Area of circle minus area of minor segment, okay. And let me continue here. Okay. which is what equal to area of circle we know it is pi r square minus area of minor segment is what, this one. Okay, which is r square over 2, what is that, theta pi over 180 minus sine theta. Now just do simple. Now let's try to take out r square common. Okay, r square, I'm going to take out r square, and from this and this one pi is common, so pi I will take 1 minus theta over 180. Okay, with this it will be into 2. Okay, minus 1, and here will be what will be here, plus minus minus plus sine theta over 2. Okay, so if you simplify this one, r square pi 360, because 2 into 180 means 360, minus theta over 360 plus sine theta over 2, and this is the area of major segment. Okay, this is the area of major segment, and this is area of minor segment. So this is our proof.